Today I wanted to do a video about solving inequalities. Well, here I've told you that what the difference is. The only difference is that when you multiply or divide by a negative number, when you're solving an inequality, you have to flip the inequality over. Negative 3x is less than 6. Then when you divide by negative 3, then x has to be greater than negative 2. Now, if you think about it, you'll understand why you need to do this. When you look at these numbers, you want 3 times the number to be less than 6. So if you substitute 1 in here, 3 times 1 is 3, 3 is less than 6. If you substituted 3 in, which 3 is not less than 2, so a number that doesn't satisfy this inequality. If you substitute 3 in, 3 times 3 is 9. 9 is not less than 6, so that would not satisfy that inequality. Same thing here. If you forgot to flip over this inequality and you had x is less than negative 2, then that means you would put negative 3 there. So if you put negative 3 there, negative 3 times negative 3 is positive 9. Positive 9 is not less than 6. So then you would yield wrong answers if you did not flip that inequality over. So let's say x is greater than negative 2. Well, what integer is greater than negative 2? Negative 1. Negative 3 times negative 1. Negative 3 times negative 1 is positive 3. Is positive 3 less than 6? Yes, it is. So that demonstrates to you why you need to flip that inequality symbol over in order to create a solution set that will satisfy the original problem. Okay, so let's look at my first example here. I have 3 plus b divided by 4 is greater than 2. So I want to find the solution, what b can be. And remember, since I have an inequality symbol, there are many answers. There's an infinite amount of answers that satisfy this. There's an infinite amount of answers that satisfy this. So since I have an inequality, I'm going to have many, many answers that work for this particular problem. So the first thing I'm going to do is, hopefully you have been told, or that you just realize, you're sort of working PEMDAS backwards when you're solving an equation or inequality or isolating a variable. So instead of getting rid of divide first, I would get rid of this adding 3 first by subtracting 3. So I'm going to subtract 3 from both sides. It'll be gone on the left side. b divided by 4 is greater than 2 minus 3 is negative 1. Now, I need to get rid of dividing by 4. How do I get rid of dividing by 4? I would multiply both sides by 4. Those cancel out. I have noticed and I have seen that many students would leave this as 4b and not reducing those. I want you to remember, when you're doing this 4 times b over 4, you're actually getting, let me scoot this to the left just a little bit, you're actually getting this 4b divided by 4 when you're multiplying by 4. And then 4b divided by 4 is just b. So be careful when you're doing that particular type of problem not to say you still have 4b left. Okay, and then I'm going to multiply negative 1 by 4. I multiplied by positive, so I do not flip that inequality symbol over. If you can check your answers to see if you've written your inequality correctly. So I'm going to find an integer that's greater than negative 4 and also divisible by 4. So greater than negative 4 would be 0. 0 is greater than negative 4. 0 divided by 4 is 0. 3 plus 0 is 3. Is 3 greater than 2? Yes. So my inequality symbol is correct. Okay, so let's look at graphing this answer. b is greater than negative 4. Okay, so I'm going to put 0 here. I like to put 0 on my number line. And then negative 1, negative 2, negative 3, negative 4. It is greater than, so I put an open circle and I shade to the right. You want to make sure to shade all the way to the right so this looks like negative 4 is excluded since it's not a solid line underneath. And then any answer that's in this darkened area and beyond is the solution to this first example. Okay, let's look at number 2. Okay, the first one that I want to do, I wanted to point out, notice there was a graph here, but look at the directions, solve and graph. Make sure you read and follow directions, unless, of course, your teacher has told you to do something else, and then still follow those directions. But okay, so I want to get this 6 away from this h divided by negative 2. I'm going to subtract 6 from both sides. So h divided by negative 2 is going to be less than 12 minus 6 is 6. I need to get rid of dividing by negative 2. How do I get rid of dividing by negative 2? I multiply by negative 2. And remember, this is like negative 2h divided by negative 2, which is just 1h. I multiplied both sides by a negative number, therefore less than becomes greater than. 6 times negative 2 is negative 12. I am going to graph this on a number line. I'm actually not going to put 0 on this number line because I won't be able to count to negative 12, so I'm just going to pick a space to put negative 12. I'm going to put an open circle because it's greater than negative 12. And where are numbers greater than negative 12? To the right or to the left? That would be to the right. So any number in this shaded region would satisfy this inequality. I don't know if you learned, and I should have mentioned it on the last one, a lot of times these answers are written in set builder notation. When you take Algebra 2, they'll be written in interval notation. Set builder notation is simply b such that b is greater than negative 4. It's just saying your solution is any number that fits this description. That's what that's saying. And then this one is saying h such that h is greater than negative 12. Any solution that satisfies this inequality. Now, I'll show you interval notation. This is set builder. I'll show you interval notation. Negative infinity on the far left of your number line. You're approaching negative infinity as you go to the left. You have positive infinity on the far right of your number line. To use your interval notation or to name your interval notation, you just read your number line. Read it from left to right like you read a sentence. Okay, so negative 4 is where this number line would start to be shaded. Negative 4 is excluded, so you put a parenthesis. If it had been a solid dot, then I would put a bracket. A bracket means it's included. A bracket is like equal to. And since it's open, it's to use a parenthesis. So it starts at negative 4, and where does it stop being shaded? It stops at infinity. So set builder notation, interval notation. Set builder notation, let's look at the interval notation here. Let's read this number line from left to right. Where, remember, this is negative infinity on the far left, positive infinity on the far right. Where does my number line start being shaded? It starts at negative 12. Negative 12 is not included, so you'd put a parenthesis. And where does it stop being shaded? It stops being shaded, which it never stops. It's infinity is what you put there. And I meant to mention here, you never put a bracket with infinity. It's always a parenthesis because no one can reach infinity. We could never count to infinity or drive to infinity. It's never ending. It goes on forever. So set builder, interval notation, and I'll show you the same on number 3, 4, and 5. Okay, so here's number 4. Okay, for number 4, I'm going to distribute first. So I'm going to have 6 is less than or equal to negative 2 times k is negative 2k. Negative 2 times 4 is negative 8. Now I want to get my negative 2k alone, so I'm going to add 8 to both sides. 6 plus 8 is 14, less than or equal to negative 2k. I'm going to divide both sides by negative 2. Negative 7, I did divide by negative number. Instead of less than or equal to, it will become greater than or equal to. Negative 7 is greater than or equal to k. Before I graph that on a number line, I hope that you can see this, and if you don't need to flip it around, it's fine. You need to have your variable on the left. K is less than or equal to -7. That way you won't shade the wrong direction. Okay, so less than or equal to -7. Again, I'm just going to put -7 on the number line somewhere. It is equal to, so I'm going to put a solid dot here for -7. And where are numbers less than or equal to -7? And that would be to the left. You want to shade all the way and even your arrow, because that indicates that it goes on forever. And remember, this is -infinity to the left and positive infinity to the right. Okay, so there's my answer. Here's set builder notation. K such that K is less than or equal to -7. So my solution that will satisfy this inequality is any number that fits this description. Interval notation, I want to read my number line from left to right. Where does my number line start being shaded? It starts at -infinity. Remember, -infinity gets a parenthesis. Where does my number line, comma, of course, where does my number line stop being shaded? It stops at -7. Does it include -7 or exclude -7? Well, it includes -7, so you would put a bracket. So interval notation, set builder notation. Okay, now notice, look at the instructions for number 4 and number 5. Do they say to graph? No, then I do not have to graph. I just need to solve. Okay, so to solve the first one, on the left-hand side, the equal sign here, I do have like terms, so I need to combine those. 8m minus 4m is 4m. Oops, plus 2 is less than -8 plus m. I didn't have any like terms over here, so I don't need to combine anything. I'm going to move my variable to the left by subtracting m. So 3m plus 2 is less than -8. I'm going to subtract 2. 3m is less than -10. I'm going to divide by 3. So m is less than -10 thirds. Okay, so there's my solution. I don't have to graph, but I am going to put it in those two notations. Set builder notation, m such that m is less than -10 thirds. That shows me that any solution, the solution to this is any number that fits this description. In interval notation, I'm going to draw you just a quick rough number line. M is less than -10 thirds, so -10 thirds would be here. I didn't really put it around any integers. It would be between what, -3 and -4. Anyway, it would be an open circle and less than shade to the left. So if I want to put it in interval notation, reading my number line, it goes from -infinity to -10 thirds. -10 thirds is excluded, so I put a parenthesis. So here's my solution, just the way you've been learning. Here's set builder notation. Here's interval notation. Okay, my last one, I'm going to distribute on both sides first. 9 times 1/3 z would be 9/3 z, which is 3z. 9 times 1 is 9. Less than or equal to 4 times z is 4z. 4 times -2 is -8. Okay, next I'm going to move my z to the right. 9 is less than or equal to z minus 8. Then I'm going to add 8 to both sides. 17 is less than or equal to z, or better written as z is greater than or equal to 17. Set builder notation, z such that z is greater than or equal to 17. Interval notation, I would start at 17 on my number line because it's greater than or equal to. 17 is included, and it's being shaded forever to infinity. So my solution, set builder notation, interval notation. I hope this helps.